Namaste to all the delegates of the 6th International Congress of Peruvian Society for Bioinformatics and Computational Biology. This is Praharshit Sharma from India, and I'm extremely grateful to Dr. David Requena for having given me this opportunity. And though I have been allotted 4 minutes, I'll try to condense my presentation to within 3. And if I may be pardoned for not having included the conference logo, kindly allow me to proceed by dividing my delivery into 4 subsections in accordance with the 4 mononucleotide bases: T thymine for theme or topic of my presentation, G guanine for genesis of my presentation, A adenine for algorithmic applications, and C cytosine for conclusions. So the topic of my presentations happens to be vigesimal radix equivalence in universal genetic code, where we are essentially trying to map bijectively and one-to-one base 2 to base 4 to base 10 to base 20, where base 2 is the boiling down of the 4 mononucleotides ACGT into purines and pyrimidines in the context of transitions transversions, whose ratio is elevated in coding sequences, and base 4 for quadruplet anticodons variants or substitutions or point cDNA mutations, and base 10 for as a yardstick of reference for the human positional counting systems that we use, as we have 10 fingers, and base 20 for the vigesimal base used by Peruvians, which happens to be a 20-dimensional amino acid space in my hyperproteinemic equation paradigm. And the genesis of my work happens to be inspired by Stephen Wolfram's A New Kind of Science, and also A New Kind of Computational Biology, authored by Parimal Pal Chowdhury, where if you have a k-state R neighborhood cellular automata, the rule cardinality is given by k to the power of k to the power of r, and if you have k1 is equal to 2, r1 is equal to 3, k2 is equal to 4, r2 is equal to 1, we neatly see, in accordance with the numerical identity 256 is equal to 256, that 2 power 2 power 3 is equal to 4 power 4 power 1, and which, if extrapolated to 4 power 4 power x, is 20 power 20 power 1, where 4 is cardinality of mononucleotides, 20 is cardinality of amino acids, x is 2.716802, that is 99.9455% close to E. So the algorithm of work as an exemplar can be proved or established using a 3-line Python script, where 30 base 10 is 11110 base 2 is equal to 0132 base 4, which is a completely complex quadruplet anticodon motif, which is 1a base 20. And the conclusions, we can neatly now one-to-one map individual genetic code as your lot of species and the coding sequences. If we align them using MaxA, multiple alignment of coding sequence alignment tool, we can arrive at consensus codomes of species. And if you have any more doubts, I'd like to take up. Thank you.